All right, so let's talk about intermolecular forces. Remember we talked about bond types and how our molecules bonded within, okay? That you have covalent, ionic, metallic bonds. Well, intermolecular forces go hand in hand with that, but it's important not to forget where intermolecular forces are exerted. They are exerted between molecules, okay? So this force that is acting, okay, and keeping these two molecules together, okay, is responsible for many things, such as, for example, the physical, okay, the physical state, if it's solid, liquid, or a gas, okay? If it's very close together, they are going to be solid. If they go further apart or have energy added to it, they will become liquid. And if more energy is added, then they will become gas, okay? But now, what decides, okay, how strong is that force, okay? Well, the inside of the molecule will determine that, okay? If inside of the molecule you have bonds that have electronegativity evenly distributed, okay, then you will have weak attractions between these two. If that electronegativity is very polarized, let's say you have a positive on one side and a negative on the other, then this force is going to be stronger, okay? So let's go ahead and talk about now today 3 different forces, van der Waals forces, which are London dispersion force, okay? Then we have dipole-dipole, and finally we have hydrogen bonding, okay? So how are we going to determine which of the 3 forces is acting? Okay, you need to take a look at the inside of the molecule. And just to summarize it, okay, I can tell you that the strength, this will be the weakest, and this will become the strongest. Okay, this is the least polarization in your molecule, okay, and this is the most polarization. Okay, so the more negative the negative is, the more attraction it will be having with the positive. Okay, so how can you determine? So we said it comes hand in hand with the intramolecular bonds. Remember our intra, okay, we had non-polar, covalent, okay, we had polar, covalent, okay. So what's going to happen here? Okay, non-polar covalent bonds, if you find this type of bond inside your molecule, what you will have, okay, as an intermolecular force acting with the other molecules, okay, are London dispersion forces, okay? So they are London dispersion, okay? They are the weakest possible. If you find polar covalent bonds, what you will have are dipole force. All right, so just check the inside of the molecule, okay? And then finally, if you find a polar covalent, okay, but that polar covalent is made up of, okay, HF, okay, all right, or NH, or OH, okay? All right, this could be inverted. FH is the same thing, okay? All right, then this is going to be the strongest intermolecular bond you have, okay, which is the hydrogen bond. All right, the strongest possible. These bonds are so strong that they hold our DNA together, okay? We can trust on these bonds information carried on through millions of years. So imagine their strength, okay? Their relative strength is, for example, okay, 0.25, okay? All right, joules per mole, okay? Then we have, for example, this dipole, okay, would have a 1.0 K per mole of a strength, joules needed per mole to separate them, and then this hydrogen bond needs about 10. So this is the compared strength, okay? Well, once again, just take a look at what you have, all right? And then based on that, decide. So